Hello guys. Hello guys, welcome back. In this video, let us learn about one more important topic regarding AWS. Now, let's say my application is running on my on-premise or somewhere in other AWS, other environments other than cloud, AWS cloud, where my application runs on this Apache Kafka. Now, what I'm expecting is I want to migrate this application to AWS cloud, where this application runs on this Apache Kafka. Now, what I'm expecting is there any service in AWS where I can able to migrate, this application to that service? Yes, the answer for that is yes. What is the service? MSK. What is that? Amazon MSK. So we can able to move this application which runs on Apache Kafka to this Amazon MFK in AWS. This Amazon MSK is an AWS service where we can able to run these type of applications. Which type of applications? Applications which run on Apache Kafka. Is there any other use cases for this MSK, sir? Yes, there are other use cases for this MSK as well. The other use cases include stream processing. It provides you a platform to process your streams. It provides you a platform to process stream. It provides you a platform to process the streams as well. Now, is there any other use cases for this, for using this? Yes, you can use this for operating as publisher or subscriber based messaging system. Even it operates as publisher subscriber based messaging system. So the main purpose of this MSK is you can able to process the streams. You can able to process streams, and even it can operate as publisher and subscriber based durability. Publisher and subscriber based message system. Now we have seen the use cases, general use case scenarios. Now the question is, for using this MSK, do I need to manage any underlying infrastructure? The answer for that is no. You don't need to manage any underlying infrastructure for using this MSK, because this MSK is a fully managed service. It's a fully managed service, fully managed AWS service. So you don't need to provision underlying infrastructure or maintain the underlying infrastructure for this MSK. Let's see more detail about this PubSub based messaging system. So what is this publisher subscriber based messaging system, sir? Let's say you have a publisher. Now you have 10 subscribers who are present here. Let's say this is the source of your application, where from here you are migrating your data to here, where this is the producer. You can assume this as producer. You have a producer and you have multiple subscribers for this. That means multiple consumers are there. This is consumer 1 and this is your consumer 2. So like that, you have multiple consumers. Now what you are expecting is you are expecting to provide the response to all your consumers. So for that scenario, this MSK is highly utilizable because it will provide you publisher subscriber based messaging system. So whenever a producer produced an item, a producer creates an item in this MSK, then immediately the data will be pulled to these consumers. The data will be pushed to these consumers, not pulling, pushed to these consumers from this MSK. So in this way, all the consumers can able to get the data same time at the same time. Let's say this producer produces the data. That is, this producer creates the data, created the data, and he created the data inside this MSK. Now what happens is whoever the subscribers are there, whoever the subscribers are there, those all subscribers will get the data. Those all subscribers will get the data in FIFO manner. In FIFO manner. So how they get the data? They get the data in, first out manner. So whatever the data that this producer will put first in this, that will get to the consumers at first. Then again, whatever the data that is next, that this producer will put the data, that will consumed by the consumers. So like that, so whenever data is put by the producers in this MSK, that data will be moved to consumers so that consumers can able to read the data. So in between, can I able to, in between, the data is changed in between MSK and consumers, the data may change. The answer for this is data is not changed along the way. So in between, the data is not changed between MSK and consumers. Whereas, so now let's have a question. So where do producer store their data? Where do producer actually stores their data? They stores their data inside topic. What? Inside topic. Actually, in this MSK, we create a topic where in this topic, we gonna store our data. We're gonna store our actual data. In this topic only, we're gonna store our actual data. So what this topic will hold? It will hold producers data. It will hold, so producers data or information. So what are the information that is produced by the producers, that will be hold by this topic. So how much period of time does this hold, sir? So based on the retention period, how much you said, that much period only it can able to hold that data. So it holds producer information for up to retention period. So up to the retention period, it will hold, this topic will hold the data. So what is the default? What is the default retention period, sir? Is there any default retention period? Yes. The default retention period is 7 days. How many days? 7 days. So the default retention period for this holding data is 7 days in the topic. One more thing is while configuring the topic, we also need to specify the storage size as well. We need to specify two things while configuring the topic. What are the two things? Is retention period, which indicates how many days you want to hold your producer's data in this topic. And storage size. Storage size indicates the topic storage size. What is that? It's nothing but topic storage size. That is how much producer's information does this topic can hold. So let's say you configured 2 GB for this topic. Now producer produces 3 GB. Now producer puts 3 GB in this topic. Then whatever the 1 GB, extra 1 GB, first 1 GB that he put, the data moved out. The data simply kicked out. That's it. Because no storage, whatever the first data that comes into this topic, the data goes out. That's it, simply. It will hold how much amount of storage size we configured, that much amount of storage only this topic can able to hold. Otherwise, if we put more amount of data, then this topic will not hold. Let's say you provided retention period is 7 days, but you put some data and you watch that data after 10 days. Do that data present in this topic? The answer for that also is no. After retention period, the data must not present under the topic. The data will be simply kicked out and data will be expired. Whereas the storage, based on the storage size you configured, that much amount of data only, this topic can able to hold. So since based on this retention period and storage size, this topic will charge you. This MSK will charge you for this topic. So while creating a topic, you need to consider this retention period and storage based on your need and consider the charge as well. Let's say I have created a topic. Now what I am expecting is I want to store my producer's information in separate partitions. So in one partition, I want to hold some information. In another partition, I want to hold some other information. Now, is it possible? Is it possible for this MSK topic? Yes, we can able to do that. That means we can able to partition. We can able to partition our storage. We can able to partition our storage of topic. We can able to partition our storage of topic for storing what producers information, right? Yes. For storing producers information, we can able to partition our topic, partition our storage topic. So by using what? By using what we can able to partition? By using partition key. What is that? By using partition key. By using partition key, we can able to do this separation. We can able to do this storage separation as well. So based on the partition key that you provided while uploading the producer data, while moving your producer data to the topic, whatever the partition key that you specified, based on that partition key, in this topic, the data is again subdivided. The data is again subdivided among the partitions. Let's say I have two partitions. Now I'm putting my data inside this topic produced by the producer by specifying partition key as one. So then my data is uploaded in this partition of this topic. Let's say I uploaded my data in my topic by using this partition key 2. Then in this partition key 2, my data will be uploaded. So now let's say I have not specified any partition key. In this case, in this scenario, so where my data will be stored? It will be stored in uniformly or randomly. It will stored randomly. So if you haven't provided any partition key, if you haven't specified any partition key, randomly your data will be written in any one of the partition of your topic. So like this, your data will be distributed and stored in your topic. Sir, can you provide me a real-time example for these producers? Yes. You can take, you can consider as an example like websites that gather information, right? So what are the websites that gather information? So what are the websites that gather information? We call them, we can take them as an example of producers. We can take them as an example of producers. Sir, can you provide an example for this? Yes. In which scenario for this publisher subscriber environment is best suitable? Now let's see an example for this as well. Let's say I have 10 websites. Like this, I have 10 producer websites. And in backend, I have again 10 services are there. Again 10 microservices are there where they will consume these 10 producers data, where they will consume these 10 producers data. Now I have 10 producers here where they produce the data, and similarly I also have 10 consumers in the backend where they all need to consume the data which was produced by 10 producers. I have 10 more consumers here. Now, since every consumer need to access data from every producer, if you provide direct connection between these producers and consumers, exactly the connections will be totally 100 connections. That is 10 producers and 10 consumers. Each consumer need to connect with 10 producers. So since there are 10 consumers, totally 10 plus 10 plus 10 plus 10, like that, 10 tens, that is 100 connections will be happened in between your producers and your consumers, right? Yes. So in order to overcome that, we can use this Amazon MSK, where we can directly create a topic in this MSK and we can produce our data and put the data in this MSK topic, and we can connect this topic to consumers. So what are the consumers that we have? Then those consumers can able to get that data. Then those consumers can able to get that data from here, from this topic. So it is very easy for them to consume this data from here, and even very less number of connections required. So in order to reduce number of connections, to decrease the number of connections, we use decoupling mechanism by using this Amazon MSK. What is this full form of MSK, sir? The full form of MSK is Managed Stream Kafka. Managed Stream of Kafka. Amazon Managed Stream of Kafka. Okay. By using this Apache Kafka, how we decreased number of connections by using decoupling. By using decoupling mechanism, we use a decoupling mechanism by using Apache Kafka, this Apache Kafka service. This MSK I am shortly calling as Apache Kafka service. By using decoupling mechanism of Apache Kafka service, we can able to decrease number of connections between your producers and your consumers as well. And one more important point is you can even implement parallelism. So by putting your data in multiple partitions, you can even able to implement parallelism while consuming or producing your topic, while putting your data under your topic by by creating by creating many partitions. We can even implement parallelism. So till now what we have seen, this producer will produce the information and that will stored under this topic. Now let's move one bit in depth where this topic will be stored, in which storage device this topic will be stored in Amazon. So where in MSK the storage will be stored. So in MSK it stores in EBS volumes, where in EBS volumes it stores these topic as well as user data. Whatever the producer produced information is there, that will be stored under this EBS volumes, where under this EBS volumes actually your data is stored. Your producer's information will be stored in topic in the form of partitions, where these topics are present in AWS. These topics are stored on top of your EBS volumes, where on top of your EBS volumes. So what do we call these storage? What do we call this storage, EBS volume storage in this Apache Kafka? We call this storage as we call this storage, that is Apache Kafka storage, as broker storage. What's that? That is broker storage. So what do we call the storage of this Apache Kafka? We call the storage of this Apache Kafka as broker storage. So how actually this broker storage will store the data? In at where this broker storage will store the data? On top of EBS volumes, this will store my data. On top of EBS volumes, it will store my data. So how it will store your data? In topics. So based on the topics you provided, like that it will store your data in EBS volumes. What do we call this storage? What do we call this whole storage? We call this whole storage as broker storage. Okay, let's say while configuring, I have created a small amount of storage. That is, let's say I created 2 GB. Now, due to my current need, I am expecting high amount of storage. So can I able to increase? Can I able to scale? Can I able to scale storage? Yes, we can able to scale storage. Storage scaling will be possible. Storage scaling. Storage scaling will be possible in this Apache Kafka. So you told scaling is possible. That means both increasing scaling as well as decreasing scaling is possible. The answer for this is only increasing scaling will be possible. Increasing storage scaling will be possible. Decreasing storage scaling will not be possible for this. So while after creating your topic, after creating your storage, after creating your broker storage in your Apache Kafka, you cannot able to decrease the storage size, but we can able to scale the storage. That means we can able to increase the capacity of our storage based on our requirement. Okay, we understood about this storage scaling also. Increasing in storage scaling also we understood. So now let's have one more question. What about durability? Does this storage provides broker storage provides me durability? The answer for this is yes. It also provides you durability because since we are using EBS volumes, it provides obviously EBS volumes provides us durability. That means withstanding with the disasters, environmental disasters. This EBS provides us the protection. We call it as durability. So this broker storage it can produce us the durability as well. Then what about encryption, sir? How can we provide encryption? Since our data is stored under EBS volumes, we can provide encryption by using two ways. Same for how you provide encryption for EBS volumes, in the same way you can able to provide encryption for this broker storage as well. Whereas here also two options are there for encryption. The first option is you can use AWS KMS, that is key management service, to take the key and you can able to encrypt your data. And second option is you can use Amazon EBS server side encryption. What is that? EBS server side encryption. You can use this encryption as well. In order to encrypt your data, you can use any one of the encryption method. So now we got an idea with how storage stored in this Apache Kafka, right? Yes. So now let's look back into use cases. We have discussed about PubSub messaging system. Yes, we have discussed about it. And we have discussed about application runs on Apache Kafka. We can able to run the applications which are runs on Apache Kafka, that we can able to run on managed streaming of Kafka. So in order to run, do I need processing? Yes, we need processing to run applications. Or else you can see the first use case. What is that? This Amazon MSK, that is Apache Kafka, Amazon managed streaming of Apache Kafka, provides you a platform to process your streams. So here I clearly mentioned a point. We can able to process our streams by using this platform, by using this Amazon MSK. So it also needs to provide us processing, right? So what do we call that processing? What do we call that processing in this AWS cloud? We call that processing in cloud computing as compute, right? Yes, we call it as compute. We call that processing as compute. So where our actual compute for this Apache Kafka will be stored, where our actual compute will be processed under broker instances. Under broker instances, actual processing happens. Broker instances are the places where our actual processing happens. So where our actual storage happens, under broker storage. Where our actual compute happens, in our broker instances. So for Apache Kafka, where storage happens, under broker storage. So in Apache Kafka, where compute happens, under broker instances. These are the places where your actual processing happens. Even this broker instances will be single node. You can even call this broker instance as node as well. We can call a single instance as a node as well. Node, we can call it as instance. We can call a single instance as node. Okay. Now, based on our requirement, this broker instance may act as a single node, or it may access multiple nodes as well. You can have flexibility to create your Kafka cluster on these broker instances. On top of these broker instances, you have capability to create your own cluster. What is that? In Apache Kafka, we can even create this Kafka cluster as a single node or else multiple nodes as well. So how we can able to create this? We can create this Kafka cluster as single node. It may be it may act as single node or multiple nodes. So in that way, based on our requirement, we can able to create our Kafka cluster. So after creating this cluster, we actually process our data, right? Yes. So while creating this cluster, can we run these broker instances in same availability zone or multiple availability zones, sir? So based on our requirement, we can even put these broker instances in multiple availability zones as well. We have flexibility to configure that as well. So if we configure that, then we can have high availability of our cluster as well. So how your Kafka cluster will be created? By creating multiple broker instances in it. By creating multiple broker instances in it, it can able to create a multi-node Kafka cluster. It can able to create multi-node Kafka cluster, where in that cluster also, in order to provide high availability, you can able to create these broker instances on multiple availability zones as well. Okay. So let's say I have hosted my Kafka cluster in multiple availability zones. That means one broker instance present in 1A region, whereas other broker instance will be present in 1B region, right? Yeah. So now let's say 1A region broker instance failed. So during that scenario, do I need to replace myself that with another instance? No. This this Apache Kafka will provide you that health monitoring advanced feature as well. So it will monitor instances health. It will monitor instances health, and it will automatically replace failure instances by healthy instances. Let's say one of your broker instance failed in any one of the availability zone. In that case, what this Apache Kafka will do is it will automatically replace the failed instance with a healthy instance. So how does this monitor that? So it can monitor health as well. Auto replacing, auto replacing of failure instances by healthy instances is one of the advanced feature. So this is one of the advanced feature which is provided by Kafka. At last, we have already seen about compute, and we have seen about storage, that is broker storage, and compute, that is broker instances. And at last, let us see my application runs on my on-premise or other cloud on Apache Kafka. Now I am expecting to migrate it to MSK. Then, so by using what service can I able to migrate, sir? If you want to migrate, for migration, you have a service. That service name is Kafka Mirror Maker. What is that? Kafka Mirror Maker. So this is one of the open source service where you can use it to migrate your application which runs on Kafka, Apache Kafka on your on-premise to AWS MSK. So this is the whole story which was behind your Amazon MSK. So this is the thing regarding storage as well as this is the thing regarding compute. And at last you also seen the use cases, and you also seen by using what migration tool you can able to migrate your on-premise. So in this way, so this is a migration tool that we're gonna use to migrate our application from on-premise to AWS. And we have seen the use cases of this MSK, that is Amazon managed streaming of Apache Kafka. And we have also seen how the data stored in the form of buffer by using in topics in partitions, and where the actual storage is stored and how do we call that storage, that is broker storage. And we have seen one more real-time example and how to perform decoupling mechanism by using this MSK. And we also seen the retention period and storage size and partition key, how to use the partition key, where to use. And we have also seen the compute in MSK, that is managed streaming of Apache Kafka. And we have also seen learn about the terms, that is broker instances and Kafka cluster, how it is created, either it may be single or multi, or it can able to present in both, and how the health of your instances will be happen whenever an instance is failure, whenever an instance failure happens, and how that instance will be modified. That also we have seen. We don't even need to do anything because this Apache Kafka will only replace that automatically. So I hope you understood this video, where in this video we have learned about Amazon MSK. I hope you understood some knowledge, or you have some knowledge recap on this Amazon managed streaming for Apache Kafka. I hope this video is contentful. If you feel this video is contentful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys. Thanks for watching again.